Hello and welcome to a bonus conversation. This time I'll be talking about Windows subsystem for Linux, and in particular from a data science perspective. So our agenda will go over what is WSL, the Windows subsystem for Linux, and why would you care and why would you use it? How do you configure it? How do you install Linux in it? And then using WSL and Linux together. So first of all, well, what is it and why would you care? Right. And the short answer is it's a way to run Linux inside of a computer without having to do some other virtualization technique such as VirtualBox or Hyper-V. What that means is that you can then run Linux locally in a pretty low overhead way that's simple to administer, reasonably fast, and gives you the ability on a Windows PC to be able to do a full version of Linux and use any of the libraries that are available in Linux. The reason you might do that is there are some components, albeit not that many, but that there's a bias, a preferential treatment in a lot of libraries towards Linux environments. Not necessarily, maybe it's not purposeful, but that's where the majority of these things come from. So if you are running on a Windows machine and trying to use stuff that was developed in Linux, there's usually some form of compatibility problems. So once you set up set up Windows for subsystem for Linux, so WSL, you go to Microsoft Store, you search for the flavor that you're interested in of Linux, be it Ubuntu, whatever, and then you essentially can install it just like any other application. And then from that point on, you can interact with it very much as though you had a Unix box, right? So very simple to use, manage, highly integrated between Windows and the Linux kernel. So what that does for you is makes it very easy to do things like copy files from one file system to another. In a different course I teach, I set up MapReduce and Hadoop inside of WSL2 so that it could simplify development and the use of those tools without having to go into a cloud-based infrastructure, having to install something like Hyper-V or some third-party tool like VirtualBox. So how do you set it up? The link on the screen is a pretty good one to start with. You basically go into the Windows features and you turn it on. It's pretty much that simple. You'll make sure that virtualization's turned on in the BIOS of the machine, but otherwise it is pretty straightforward. You can do so from a PowerShell instruction, or you can also do it just through the UI. So PowerShell has the nice sort of approach that you don't have to restart the computer or anything else. And then you'll want to install, most likely, depending upon the version of Windows you're running, the update to the Linux kernel at the URL that's listed there. And then once you've done those things, then you'll want to say that you want to use WSL2. So why 2? And the short answer is it's better, right? Obviously it's the newer version, so it's obviously going to be better, ideally. But most of the time you're going to want to use WSL2. It is the active path of development. They changed the way that integration occurs. It is very seamless at this point, so that it's very painless to use. So to install it, you open up Microsoft Store. You search for WSL and pick whatever flavor of Linux you're interested in, or you may want the Windows Terminal or the Windows Terminal Preview. Those make it very easy to access it as well. So you'll pick on one of those distributions and basically it'll install, and then once it's done it'll open up. Generally speaking, I like the Windows Terminal because it allows you to do tabbed interaction. So I'm searching for it. So this is the terminal preview, and if I click on here and say go to Ubuntu, I open up in a different tab. I'm on to my Linux box or my WSL2 implementation of Linux. So up to you, but it's something that I find useful. And so after you've downloaded, you'll need to basically open it up the first time, and you'll do so through, generally speaking, the icon that shows up whenever it says it's installed. When you do the run, it's going to say what you got to give it a username to essentially log in with and a password. Once you've done that, you'll want to do things like install Anaconda and what other tools that you use. You can do this command to see the version that is running, so cat and then /proc version. So you can see the version that is running. And then you can also access your local hard drive through a mount point inside of WSL. So this is I'll go to my home directory, a bash shell with a Linux file system. So if you go and do ls/root, it'll look pretty much like what you see on most Linux systems. If you go and look in the mount, you'll see that there's C and D available to you. That is where my computer has a C drive and a D drive. So if I do ls mount/C, I'm looking at the root of my C drive. So very easy to navigate, switch between the file systems. Also, you can access the Linux file system by going down in Windows Explorer and clicking on Linux, Windows File Explorer. And you can see here it shows me the various types of them that I might have. The one we're on right now is this Ubuntu 20. And again, I can go into Home and go into Allen, and that is the same directory where we were at a moment ago. So if inside of here, if I click the CD to go back to my home and do ls-a, it'll show you its exact same files. Linux by default hides all dot files from you. They're assumed to be kind of housekeeping, similar to a hidden file in a Windows environment. Again, the reason you might care about this is that there are things that are only available inside of WSL, and in fact, or inside of Linux, and in fact, a lot of products are deprecating their Windows implementations because of the availability of WSL2 and WSL. So, for example, I was looking at a code scanning piece of software that looks at open source software and extracts the licenses that are associated with it, and they said basically that the Windows version was going to be deprecated because of the availability of the WSL2 system. As also Docker, we'll talk a little bit about that in a minute, but Docker is a containerization platform. Docker Linux images are a good thing. Docker trying to run Windows container images, not a good thing. So what they've done is replace the support that previously was being done through a form of virtualization with the WSL2 backend. So now whenever you're running Docker on a PC, you're actually running the Linux version of things. So very cool. So also a nice thing that they built in is the integration with code. So if you type code in, that's basically installing a Visual Studio Code server inside of the Linux distribution. And what that allows you to do is edit files that are local to this file system using your rich editor without having to do anything interesting like going over here and navigating and right-clicking and saying edit or open with code. Instead, from a command line inside of the Linux environment, you're able to open up a code editor that will pop into the Windows environment, not in the Linux environment. Also, recently, I don't have a screenshot of it, but they've extended support to graphical Linux programs so that you can now run things that have a graphical UI inside of WSL2, and they call it WSL2G for graphics. But that's actually was announced to be general availability during the last, I think it was Code a couple weeks ago. So there is tight integration between the two environments so that you can do really interesting and productive things. You don't have to use a Linux editor. You can use one that you're familiar with, such as Code. You can also do things like run Jupyter notebooks from inside of the WSL2 and access them with a browser from your Windows-based machine. So you can get kind of the best of both worlds. You can get the power, robustness of a Linux environment, and then the ease of use and flexibility that Windows brings. Here's an example of installing PyTorch onto the inside of the Jupyter Notebook running inside of WSL2. PyTorch is a thing that is optimized for GPUs. It's a a deep learning neural network sort of environment. And what this is doing is allowing the Windows subsystem for Linux to access the GPU in the base machine to do GPU enhanced processing. And the reason you care about that is because a lot of times whenever we're doing things like deep learning, it's a whole bunch of matrix manipulation. A lot of matrix math is going on, lots of multiplications and so on. And GPUs are really, really good at that. And if you do something without a GPU, it's significantly slower than if you can utilize a GPU. So that's the basics of why you would care. And sure, you could probably get GPU working in your base system with Windows and so on, but there's a whole lot richer support for it, again, inside of the Linux world. So that's part of why you might want to go that way. Here's an example of showing TensorFlow, an alternative sort of neural network sort of approach, and doing the equivalent of hello world, right? I'm saying 1 plus 3 and 2 plus 4 and getting back 4 and 6. So it is, in doing so, using my NVIDIA GPU processor. So cool stuff. You're able to run things inside of an environment that's nested in another environment but has access back to the base environment. And so you really do get the benefits of both environments to the fullest extent. Here's some really useful links that you might want to take a look at if you're so inclined. You may or may not have an interest in doing GPUs at this point, but depending upon where you go with your career, you may end up wanting to. This is basically just saying how you can verify that CUDA was properly installed. And it is possible to run multiple versions or instances of the same distribution, but you have to kind of do a little bit of a hack. You have to export it using the WSL -export, and then you have to import it back in, giving it a different name. So there's some oddness there, but it does work. An example of running Docker to where it'll actually use the GPUs and the Windows subsystem for Linux. So very cool stuff. And with that, I'll wrap it up. If you have any questions, let me know. That's what I'm here for. Otherwise, I will see you on Wednesday. If you have any questions about any of the assignments or the last assignment in your case, let me know. That's what I'm here for. Stay safe, and we'll speak again soon.